I want to start talking about the domains of the new functions that we can build. Remember, the domain is the set of all possible inputs, so every number that x could be. So what I'm going to do is I'm going to first of all just state the domains of f and g in interval notation, and then we'll start taking a look at the functions that we can build out of f and g and see what their domains are. So if I look for the domain of f, I notice that f is a fraction, and a fraction is just a division problem, and we always have the rule that we cannot divide by 0. So whatever I've got on the bottom is not allowed to be 0. So I've got the absolute value of x minus 2 minus 1 can't be 0. Now in solving this, remember I want to isolate the absolute value first. So I'm going to add that 1 over and say the absolute value of x minus 2 cannot be 1. And then I know there are two numbers that have an absolute value of 1, plus and minus 1. So x minus 2 can't be either one of those numbers. So x minus 2 is not plus or minus 1. Once I've isolated the absolute value, I can say the quantity inside can't be plus or minus the number that's on the other side. Now that's actually two separate things for me to solve. X minus 2 can't equal 1, and x minus 2 can't equal negative 1. And I do need to work those out separately, because in both cases I'm going to add 2 over to the other side, but adding 2 to 1 is a very different problem from adding 2 to negative 1. So here I'm going to get x can't equal 3, and here I'm going to get x can't equal 1. Now, if I were to graph that on a number line, not absolutely necessary, but it helps me to visualize what's going on, my domain is everything except those two numbers. So notice that gives me 3 separate intervals. So I would have for the domain of f, we're going to have everything from negative infinity to 1, union everything from 1 to 3, union everything from 3 to infinity, where I've got parentheses around every single endpoint. All right. Now, if I look at the domain of g, for g was an even root here. It's a square root. So I want to remember the rule there is that if I'm taking an even root, I can't do that if the quantity under the radical is negative. So I know that 2x minus 4 has to be bigger than or equal to 0. So that means 2x has to be bigger than or equal to 4, x has to be bigger than or equal to 2. And I can probably go right to the interval notation. Whoops, that's going to be everything from 2 to infinity, and this time I can include the 2. Now, if I start thinking about what I'm going to do if I'm combining these functions with arithmetic, let's just get a formula for f plus g of x. Remember, that just means I've got f of x, and I'm going to add g of x to it. Okay. So that would give me x over the absolute value of x minus 2 minus 1 plus the square root of 2x minus 4. And here, there's really nothing more for me to do. I've written them both out. They're not like terms. This is a square root, this isn't. So all I really needed to do was write those. If I think now about what the domain is going to look like, well, I have to be able to do 3 things. I have to be able to evaluate f, so my x value had better be in the domain of f. I have to be able to evaluate g, so my x value had better be in the domain of g. And then I have to be able to add the 2 results together. Well, with addition, that doesn't give me any new restrictions. I can add any 2 numbers together that I want to. Same thing is actually true for subtraction and multiplication. Those arithmetic operations can be done with any pair of real numbers. The only arithmetic operation that comes with some restrictions is division. So what's going to happen is that the domain for f plus g will be the same as the domain for f minus g, will be the same as the domain for f times g, and that's just going to be the intersection of the domains for those two pieces. Okay, so let's write that out. Domain of f plus g of x, f minus g of x, and f times g of x is the intersection of the domains of f and g. Because all I need to do is be able to evaluate each part. Once I've done that, I've got a result, I can do the arithmetic. We'll take a look at division separately, but what I'd like to do now is figure out how do we find what that intersection is. Because with unions, we actually have to write the union symbol. The symbol for intersection is an upside down U, but we don't really need to know that because we should be able to calculate what the intersection is so that we never have to write the intersection symbol. So what I will often do is I find the graphs here to be fairly helpful. Okay. So we said for f, it was everything except 1 and 3. So I've got that shaded in purple. I'm going to use a different color for the domain of g. That was everything from 2 on. So I was including 2 and everything to the right. Now what I want to do is this gives me the domains of f and g individually. If I want to be able to evaluate f plus g, or f minus g, or f times g, I need it to be in the intersection, which means I need it to be a number that got shaded both times. Okay, so this was for f, this was for g. If I want to find the domain of f plus g, okay, I'm looking for everything that got shaded twice. If I did this in purple and red, if I had done this in yellow and blue and I imagined overlapping them, yellow and blue make green, so it would be all the numbers that turned green. I didn't use yellow and blue. I have a yellow marker. It doesn't show up very well on the whiteboard. Okay, so I can see nothing over here got shaded twice because I didn't start shading here until we hit 2. But if I look at 2, 2 was shaded in purple and 2 is shaded in red, so that counts. And it looks like almost everything to the right of 2 got shaded twice. The only number that didn't is 3. 3 was only shaded once. So if I want to be able to evaluate both f and g, I need to be one of these numbers here. So now if I write that in interval notation, I can see that's going to be from 2 to 3, union 3 to infinity. Okay. So I find it helpful to find the individual domains first and then find the intersection. I'm going to give you a problem to try in the before we start the next video. Let's get a new f and g. Let's let f of x equal 2x over 3 minus x. And let's let g of x equal the 4th root of 2x plus 1. Okay, and I want you to find the domain of f, g, and f times g of x. Okay, so find me a formula for, find me the domain for these 3 functions, and go ahead and write out the formula for f times g. Find me that formula and simplify it as well. And then we'll take a look at that in the next video.